So in 6.5 part 1, we're now going to try to replicate everything we did in 6.3 part 2, but in radians. So we're going to start with our quadrantal angles in radians. So we've already done this, but I always find the more times you hear this, especially in radians, the better. So if we were going to look at our quadrantal angles, we would start at 0, and then we've got pi by 2, pi, 3 pi by 2, and 4 pi by 2, or 2 pi. Now, as I just started saying that this could be 4 pi by 2, when you're thinking about this, because we're going to also be doing these as coterminal angles as well, you could count these as 1 pi by 2, 2 pi by 2, 3 pi by 2, 4 pi by 2, 5 pi by 2, 6 pi by 2, 7 pi by 2, 8 pi by 2, and so on. You can also read it in the opposite direction and think negative pi by 2, negative pi, negative 3 pi by 2, and negative 2 pi. And we should also put in maybe those other coterminal angles like 1 pi by 2, 2 pi by 2, 3 pi by 2, 4 pi by 2. We could put 5 pi by 2 in here. Maybe 6 pi by 2. Right? Or 7 pi by 2. And 8 pi by 2, which would also be 4 pi. And so on. And I guess this one I should also put could be 3 pi. Right? Maybe not comma, but equals. So when you're talking in radians, it's the same as everything that we did in degrees. It kind of just feels a little bit different, right? And so since we just did coterminal angles in radians and complementary angles in radians, hopefully this doesn't feel too new, but I find it is good to see them sort of all together here. So if I then asked you to find the function value using coordinate points on the unit circle, giving exact answers, of something like cos of pi, the first thing we would do is identify where pi is. Now pi is here. So then we're going to give the coordinate points, which would be negative 1, 0. Then I know that cos is x over r. So it's going to be that negative 1 over a radius of 1, which means the cos of pi is negative 1. If I asked you to the tan of 3 pi by 2, depending on how you get there, you could go 1 pi by 2, 2 pi by 2, 3 pi by 2. On that negative y-axis, you'd have a point at 0, negative 1. Tan is y over x, which would be negative 1 over 0, which is undefined, or does not exist. The next one would be cotan of negative 7 pi. So when you're counting by pi's, I mean, you can do the 1 pi by 2, 2 pi by 2, and so on, but you could also go 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi would be here. So 7 pi is coterminal with pi. You could also get there by thinking that if you took 7 pi and you subtracted 2 pi, you'd get 5 pi. And if you subtract 2 pi again, you get 3 pi. And if you subtract 2 pi again, you get pi. So you could find that by using the coterminal angle idea. But again, I like to just count like 1 pi, 2 pi, 3 pi, 4 pi, and so on. I should have read that in a negative direction, but you know what I mean. So then I'm going to put in my point, negative 1, 0. And then I'm looking for cotan. So cotan, whoops, that's cos. Cotan of any angle is x over y. So the cotan of negative 7 pi would be x is negative 1 over 0, so it's also undefined. And then lastly, sine of negative 7 pi by 2. So for this one, I'd be reading, right? This is negative pi by 2, negative 2 pi by 2, negative 3 pi by 2, negative 4 pi by 2, negative 5, negative 6, negative 7 pi by 2 would be here. And so I'm having a point 0, 1, and then sine is y over r, which would give me 1 over 1, which is 1. All right, so that is your quadrantal angles in radians.